So nested models. So so remember, theta equals the parameters estimated. Okay, theta is the parameters estimated. And that usually involves a lot of multiple values that you estimate. A, B, C, D, out to, we'll say, T. R, S, T. So I'm estimating all the values, variables A, B, C, D out through T. Now, this is theta. If the model structure doesn't change, I'll just leave it there. If the model structure doesn't change, but you add more parameters to be estimated to this list. So for example, what I'm going to do is I'm going to add X, Y, and Z to the list. Okay. Then we say model 1 so then we say model 1 not model 1 is nested in model 2. So there's more things being estimated in model 2 than there are in model 1. But the key is everything that's been estimated in model 1 is estimated in model 2.
So it's that you're adding lines and not taking them out.
Correct. Correct. Okay, so that's the key. So model 1 is nested in model 2. So theta now for model 2 is A, B, C out to T, and then X, Y, and Z. Now I'm going to do something a little different. I'm going to go back to my model, because remember, there was also something else in my model that was coming up, which was that A3 seemed to be doing something strange with B1, it's B1. And I took that as a consequence of A influencing B1. I'm going to get rid of that. And hey, I've got multiple things. I've got 3 predictors for A, 4. I'm just going to get rid of A3. Let's see what happens when I do that.
Without going back to the MIs to see if A3 and B1 are still, or whatever it is, are still.
Well, if I technically would go back to the original one, the one that, so if I went back to MIs, I'd go back to the one that had.
Oh, not the modified version?
The first modified, where I added the. So here I've added the correlation between my 2 M's, because those were, we feel, in fact, in retrospect, we probably should have put that in right away, the education level. So when I look at the statistics here, A to B is 17, But when I go down to that A3B1 combo, where's it at? That's higher. That's actually 22.
Yeah.
Now, if I look at it and say, I'm not sure I can connect B1, I want to go to college with how much I believe our house costs. Well, I'm not sure. So what I'm going to do instead is I'm just going to say, get rid of it. That's the nice part when you've got a bit of leeway with your variables. If you can throw something out and still have a good measure, you're probably okay. Now notice, look at my degrees of freedom. My degrees of freedom have really changed here. Because technically now I've got 32 degrees of freedom with 34.82, and I don't have a mediation. I still technically have true mediation here. I don't have a path from A to B.
Oh, you took out.
Right, I went back to
Okay.
my original change.
Oh, okay. I left it.
So I've got M predicting B, A predicting M, and that's it.
Right, so are you trying this as an alternative then
Yep.
to making it partial mediation?
Yep.
Okay.
Yep.
That's why I didn't understand why you were going back to the one.
Oh, sorry. Yeah.
So I was like, I thought you have to keep adding on.
Now, the key is now my structure is actually not the same anymore. And it's made most evident because I don't even have the same number of variables anymore. That's why we had such a significant change in the values. So what I'm going to do now is bring up the eStat GOF stats all. I'm going to take advantage of the AIC and the BIC. I'll just use AIC, but it's a comparable calculation. So AIC for this model is 22440, 22440.598. Now, I want to go back to the model that had 41 degrees of freedom, the one where I only added the modification index. Where I
The
only,
error.
no, I'm sorry. No. I want to go back to the partial mediation model. I'm going to go back to the partial mediation model. Hopefully I looked at the GOF for that. Is this the partial model? Yep. Okay, the AIC for the partial model is 24251.871. 24251.871. The AIC for my other model is 22440.598. Now, these models now, if I go back here, these models are not nested. I'm in this category here now. These models are not nested models. I can't do the chi-square test because the structure of the structure is different. If I really, really wanted to, I could make them be nested. But to do it, I would probably be shooting myself in the foot. The truth is these are not nested models. So the next best thing I can do is I can say, well, the AIC is a standard model using my data set. It's a standard measure that is unreferenced, but is referenced, is somehow connected to my data. In other words, I don't know what good is, where the good cutoff is, but I know that if I get a different AIC with my data, the lower the value, the better it is. Now, some people have argued that you could do an AIC chi-squared test, just like we did. Most people say, no, just kind of look to see that you've got a smaller value. Well, we went from 24,000 and change to 22,000 and change. So that's more than a 10% drop in the actual value by taking out A3. Yeah. So now it becomes tricky because now what we have is two competing models for the same data set. We have the model that included A3 and was justified by partial mediation. And we have the model that was true mediation with one of the indicators missing. And welcome to the world of SEM. There's no clear-cut answer. There's no clear-cut answer.
And A3 would have made it in when you did the CFA if you had done that.
Yep, because they were all coming
Is
out.
it all-
They were all
okay,
coming out
okay,
pretty
okay.
strong. Now, I can tell you because I made up this data. I like simulated the data set. I went in and forced A3 to predict B1. Okay? So I know that there's something, I knew that was happening. In real life, we have no idea what that predictive, what's causing our data to be that way. So this is where we kind of end up. And people say, well, what do I do? Well, you actually get to make a decision, but you got to present both sides. You got to be as transparent as possible, and then make your argument. I think theoretically, the partial mediation model makes more sense. Or, no, I really can't see SES influencing someone's academic aspirations. I can see SES predicting other things which affect their aspirations. So I'm going to say A3 probably was a poor predictor, or is just a flawed measurement item. That happens. That happens.
This would be like asking kids to fill out.
Yep. Or
So,
middle schoolers. In my brain,
they
I was
have no idea how much their house is worth.
right, but that's okay because you have ideas of it. So if you ask someone if they've got 1 million books,
Yeah.
and they say, "Oh yeah, we've got millions of books,"
Yeah.
that's sometimes more indicative of the fact that you have like 580 books.
But you have more than the kid who thinks he doesn't.
Bingo. That's where it comes. Yeah, that's where it comes into. Yeah. All right. So this kind of walks us through now all of the actual. So at this point, we're ready to start thinking more carefully about just getting our own models to run and things to change. And I think we should just start using the next couple sessions to play with them a little more. And then we'll do group comparisons. That's the next big thing. So the next question, the next hypothesis question is, how do you actually do group comparisons? And that's where we essentially say we're running 2 separate groups and running the SEM on each and trying to compare them.
And we can do more than 2 groups.
Mm-hmm. Yeah, you can do as many groups as you like. Though I wouldn't recommend more than 3 or 4. It gets really messy really quickly. All right, so we've got a number. So there's still, we have like I think 6 more weeks left in the term. So there's plenty to keep us busy. But at this point, if the class actually ended here, you could go and start doing this stuff. Now, there's things that you'll encounter like non-positive definite matrix that's going to come up, and things where things crash and burn, and you've no idea why. And we've only just barely scratched the surface to have an idea of that. But some of that just comes with practice as you do more of these. All right, I'm actually going to go ahead and turn off the recording here.
Can I ask,
Oh, of course, yes.
do you have the Excel sheet still up? With the
Yeah.
nested models?
Yeah.
I get it, but for some reason I got lost. So the 16.62, that's the change in the part.
That was the change amount.
Okay, and then what's the 4.56 again?
That's the p-value associated with that. So on 1 degree of freedom, the probability of seeing a chi-square of 16 and change is point.
P-value.
Yep.
But it's actually like 0.000.
Right.
Okay, that's why I was getting confused, because if it's above 3.84, then it's a statistically significant change, right?
Yes.
The chi-square distribution?
Yep.
So you just like are looking for it to be above 3.84.
Yep.
Okay, that's what that was.
Yep. Yeah, you could use it that way as well. 3, 4, 5, 6.
Okay.
Yep. Okay. All right. All right. I'm just turn off the recording here. See if I can.